Okay, let's keep rolling with a couple examples here to illustrate the basic derivative rules. First one, f prime of x. Well, I can do all three pieces separately. So the first one, 2 can stay out front. And then the 6 comes down. You have x to the 5. Remember, the exponent comes down, then you subtract 1 from the exponent. The second piece is the simple one, where nothing changes. E to the x is its own derivative. And then finally, the derivative of 4 is 0. So cleaning this up, I get 12x5 plus e to the x. Next example. Now, I'm going to rewrite f of x so that I can use my power rule. So I can write it as 7x to the minus 2. Okay, I want to do this because my power rule says something about x to the power of n, not 1 over x to the power of n. Okay, it says this. So I want to use this formula. So I'm going to rewrite this guy like this. And then my next one, this guy can be written as a fractional exponent. So you got to remember that the 3 ends up as the top of the fraction. So it's going to be 3 over 5 for my fraction. Then e to 9 won't change. Okay, so I have not found, notice I have not found f prime yet. This is still just f of x, rewritten to make my life easier. Okay, now I'll find f prime. Okay, you descend the minus 2, and you subtract 1 from the exponent. I'm just using this rule here, and you're going to use this rule over and over and over again. So definitely don't forget this one. But don't worry, you won't. You'll just use it so much that you'll never forget. I'll use it again right now. 3 over 5, x to the 1. Now I subtract 1 from the exponent. So I'll just write it like that for now. So 3/5 minus 1. And I'll clean things up in my next step. E to 9, that is a constant. So the derivative is 0. Now, my next, I forgot to put a prime on this guy. So put the prime in there. I'll put it in red just to make sure we're on the same page. F prime of x is negative 14, x to the minus 3, plus 3/5, and if I take 3/5 and subtract 1, I get negative 2/5. And that is all. If you wanted to, you could rewrite this as minus 14 over x cubed plus 3 over 5 x to the 2 over 5. You could do that if you like, but I don't require that usually. Okay, moving on. Finding a tangent line. Finding a tangent line, and we'll also do a normal line, which I'll explain in a second. So we've done this before, but we'll see it's much faster now. F prime of x is going to be very quickly found to be 2x to the 1, right? That 2 comes down, subtract 1. So f prime of x is just 2x. So f prime of negative 1 will be negative 2. I plugged in x equals negative 1 right here. So there we go. I'm halfway towards my tangent line. It's going to be minus 2x plus b. Then you plug in your point as usual. And what do you get? You get negative 1 for b. So y is equal to minus 2x minus 1. So that's the tangent line at this point. Now the normal line, what you want is the line that goes through this tangent point, but is perpendicular to this line here. So normal line. So I want the perpendicular slope. Perpendicular slope is, well, you take this slope you found and you do what's called the negative reciprocal. So you take the reciprocal, which is 1 over -2, and then you make it negative by sticking a minus on top. So this is called the negative reciprocal. Is going to be how you find the perpendicular slope. So my normal line is going to be y is half x plus some b. But then my point is again -1, 1. And we will plug that in and we will get 1 is equal to -1/2 plus b. So b is 3 over 2. So my line, my normal line is y is equal to 1/2 x plus 3 over 2. And there you have it. Let's draw a little picture to see what these look like. So I'm going to draw the two lines. So -2x minus 1. Where can I do that? I'll do it over here. Draw these two lines. So we're going to go like this and like this. I'll have a look at my lines. What do I need here? I need maybe 2 up here would be sufficient. Yeah, I think so. That means 1's here, and -1 is here. Plus, oops, -1. Just talking to myself, don't mind. Now the point in question was -1, 1, which is right about here. Now I know both of these lines go through this point, but one of them has slope half, and one of them has slope -2. So if I go from this point using a slope of -2, I think my next point will be down here. So something like beep, 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 beep. Oh, that's not very straight, but you get the idea. And then my normal line will go from this point with a slope of 1/2. So my rise over run is 1 over 2. So I would put the next point right here. Something like that. And then the original curve is y equals x squared, which, well, we said this is a tangent point here, right? So why don't we just draw it like this, tangent point, and it comes down and goes to the origin, and continues up here. Ooh, continues up here. Et voila. So my orange line is my tangent line and my green line is my normal line.